tutorial over here. Just a second. Yeah. So yeah, the first question, I would say that was kind of easy questions, and most of you were able to do. But still, we'll discuss it. Yeah. So the first question was Vidit learns mathematics. So the question stated that. Okay, do I show the question as well? Just a second. Okay, we'll see the question in next one. Next, like from the next question only. Let's just dive into the solution for A. So we were given with two conditions. Okay, so one condition was to was to check if the units digit was 0 or not. And on the basis of that, what we had to do, we had two options. Either we decrease the n by count of n by 1, or like we have to remove the last digit. So what we do over here is, and we were also given with k, like we were asked to write the algorithm or run the algorithm for k times. So in Java, what we do, or in any language, first you have to take inputs. So scanner is the class in Java through which you take inputs, and this is the first, this is n that we wanted, and this is k. Like n is the number and k is the number of times that you have to run the loop. So directly putting into the for loop, or you can also use a while loop. And in that, what you have to do is simply put a if else check. So what I did over here is, if the last digit is not 0, so what n percentage 10 does. Okay, that's pretty basic stuff. So I won't be going over it, but yeah. So this is the last digit. Like percentage tells you the last digit. If you percentage it with 10. So if it's not 0, you decrease it by 1. Else, you remove the last digit. N by 10. For example, you have 23, and it's an int. So basically, what by 10 does that. So 23 by 10 becomes 2.3, and zero point 0.3 will be removed because it's an int. So that's what is happening over here. Even if it's a longer int, that will happen. But the problem occurs when if you take a double over here. So in double, what will happen is 23 by 10 will be 2.3, and that will mess up the solution. So yeah, this was a pretty easy question. Yeah, so we can move to the next one. Also, yeah, just let me pull up the questions also. I have to re-log in. Okay. Till then, any doubts till now, regarding inputs or like anything? No problems, right?
Hello.
Yeah, hello.
Yeah, in the first question, wasn't it like the condition was if there is a zero at the end, then only we have to divide by 10.
Yeah, so that's what we check, no? If the
So if it is 23, then we won't divide it by 10, right?
that was just an example, yeah. That was just an example. I was just
Yeah, so we don't need double in this code, right?
don't need double. I was just explaining that if you took double,
Yeah, yeah, yeah.
that would mess up the solution.
Okay,
Yeah.
sure.
Just a second. I have the contest. Yeah, here's the contest problems. Yeah. Yeah, so the second question was night shift. Okay. So this is like pretty shit. We don't need to read this. All these. Okay. Okay. The question starts from here. So there are like guards. In and like they all stand in a circle and take one hand, showing a number of fingers 1 to 5. So as you all already know the question, I won't be running over like these lines. So Rajesh can show 1 to 5 fingers. So moving on, the total number of fingers is summed up, and starting the count from Rajesh, the person on whom the count stops has to work at the night. Yeah. So the question stated that Rajesh has to show some fingers, either from ranging from 1 to 5, and then they count. Then they stand in a circle, and the count starts from Rajesh. Um, and if at the end count stops on Rajesh, he has to work. Like count stops and whoever that guard has to work for that night. So but Rajesh plays the tricks, and player knows beforehand the number of fingers each card will show. So he needs to show the number of fingers where he will save in the shift. For example, if there are 3 guards in total, okay, this is just some example. So yeah, so as you all are starting, the most important thing is to look for input and output before go directly jumping to make an algorithm. So first of all, you have to look at the time like constraints. So here it is given that g is an integer with 1 to 100. Okay, we can move on. They are denoting the number of guards excluding Rajesh. Yeah, so this is excluding Rajesh. You have to take this point I will just bold. Yeah, so this is important point. The next line contains the number of fingers shown by each separated by a space. Yeah, the output is okay. So yeah. So this is the editorial like I wrote. So we can directly look at a example from here. Look at an example. So let's take an example of 2 and 3 4. Yeah, so two people, as I showed you here. Yeah, so this question says that denoting the number of guards excluding Rajesh. So two people, these are the 2 guards except Rajesh, and in total there will be 3. And fingers shown by other 2 guards, we are given that we have to sum all these like 3 4, and array can go on like 3 4 1 2, like whatever. So we have to sum those, and these are the fingers shown by these 2 guards, and Rajesh has to show some fingers so that he shouldn't work. So we make a circle, or instead what we do is we open the circle and make a line. So starting from Rajesh, counting these 7 numbers. So this is basically the thought process. You have to go through these types of questions so that you will be better able to develop these things. So starting from Rajesh, the count will go as 1, 2, 3, 4, 5, 6, then 7. So it ends on Rajesh. Now we don't have an option to show 0 fingers. If let's suppose we had an option to show 0 fingers, so that wouldn't be counted as 7 is ending on Rajesh, and we don't need that equation. Like, are you getting the point? So if zero, if let's suppose Rajesh shows 0 fingers, and if it's allowed, the count will end on Rajesh and he has to work, which is not required in the question. So let's suppose Rajesh shows 1 finger. So what will happen is the total count will go to 8, and the counter will end on person 1. So this is valid because Rajesh doesn't have to work in this case. Moving on to the next one, he shows 2 fingers. Then he moves it goes on to person 2. Again, as it's a circle, it will go from here to here, jump right over here, and again 9 will come over here, and it will be on Rajesh. 8, 9, 10. Okay, 10 will be here, and it will be on Rajesh. So that's not valid. Again, you do for show finger 4 and show finger 5. So that's the thought process behind this question. And yeah, the logic is clear now. We just have to code it. So as it says, the total 4 times valid, which is our desired result. Yeah. So one major thing that comes over here is how do you check where the count ends? So again, we take a look at the modulo operator. So let's suppose I'll just this is so many tabs. Yeah. So let's take an example. This is Rajesh. This is person 1. This is person 2. 1, 2, 3, 4, 5, 6, 7. Yeah. So if it comes on 8, let's directly write here 8, person 1, 9, then we have 10, then we have 11, then we have 12, 13, 14, 15. So so the main thing that you needed to see here is how modulo, how to incorporate modulo over here. So if you see 1, 4, 7, 10, 13, 11, they both all these numbers end on Rajesh. So if you take the percentage like modulo operator and divide it with 3, 2 people plus 1 is Rajesh. So it will give you so what is 10% is 3? It is 1 only. So as Rajesh is standing on the first position, the percentage the modulo operator will give 1, and you will directly know that it's on Rajesh. So that's the logic behind this code. So if you do percentage n plus 1, that is the total number of persons and the total fingers, it will give you 1. And if it's 1, you know that it ends on Rajesh, and we don't need it. Yeah. So moving on to the code, again, instantiate a scanner class. We take n is this number, and for these, what we do is we run a for loop. And for example, first of all, what we will do is we have to add them up. So while taking input, we'll add then only. Like for example, you could also, what you could also do is first make an array, uh, append all the numbers, append all the inputs in that array, and then sum it up. So instead of making an array, we'll directly add inputs to the variable. So this is the total number of fingers shown. So running over the loop, it will take each number and it will add it up. Now the main thing, the main part of the question comes. How do you find the number of, how do you find the number of count? Like for example, Rajesh shows 2 3, Rajesh can show 2 3 4. So these are the number of fingers he can show. How do you add these up? Like, you know, by logic, like you know in your mind that these are the cases that you have to add, but like how do you code it? So for that, what we will do here is we'll look at a brute force method. So what does brute force method say? Brute force says that you have to consider all the test cases, and then you have to take the desired ones out of it. So the possible number of fingers can be from 1 to 5. So 1, 2, 3, 4, 5. And in this for loop, what we are doing is we are taking all the number of fingers that Rajesh can show. So these are all the cases. So basically, this is brute force. We are considering all the cases. And let's suppose Rajesh shows one finger. The target will be, this is the finger shown by other guards, as you all know. Like we added this up, like this is 7. If Rajesh shows one finger, then 7 plus 1 will be 8. And you have to take the modulo operator with n plus 1. So that's it. That is what is happening over here. And if this target is not equals to 1, like this doesn't end on Rajesh, then you simply, what you do is you add 1 to the answer. And after this whole loop is done, you print the answer. Now you get the idea, I guess. Any doubts till now? I guess it's clear. So the main thing was that you have to use brute force. Brute force is basically like running all the test cases, like not test cases, running all the cases and picking the desired ones out of them. I guess it's clear. I'll just check. You can also write in the chat. Just give a thumbs up so I know that it's clear. Okay, cool. Next question. Where is the question? Yeah. This is the editorial. Yeah, this is the question. The mind reader. The next question is mind reader, and it says that you are at a party. You are at a party, and mind reader decides to choose you as a volunteer. And okay, he asks you to remember two numbers on thick of known two numbers A and B. Then he asks you to prepare a list of number which all device. Okay, let's directly go to this. So here's a mind reader. Let's say mind reader. He asks you that you have to choose two numbers. For example, let's directly take the test case only, 8 and 20. And then what happens is you forget the number, but you remember the list of all the devices. For example, what are the devices of 20? So 1, 2, 4, 5 is also there, 8, 10, okay, and 10 and 20. So these are the devices of 20. So these are the devices of 20. And what are the devices of 8? 1, 2, 4, and last is 8. So what you remember is the list of all these numbers. We'll copy it and we'll copy this as well. So the question asks you, so if the question was in another way, let's suppose like in the reverse way. For example, it gave you two numbers and you have to like print the list of all the devices. It would have been really easy. Like you could directly like take all the devices, add it to a list and print it. So that was pretty easy. But the question is inverted over here. You have to find the two numbers from this list. You know this list. So how do you find two numbers out of it? So moving on to the editorial again. Yeah. So as I wrote over here, every integer is a divisor of itself. As you can see, 20 is the number and it's divisor of itself. Like it's the largest divisor of the number. So a number itself is the largest divisor of itself. I think I'm like right on this. Yeah. Let's take a okay. So now you know that 20 is the largest number, like one of the numbers that we need. Is it clear till now? Like 20, how did we get 20 as one of the answers? Like there will be two answers, one is A and one is B. So let's just say A equals 20. Is it clear to you guys like how we got 20? What if takes a lot of time plan? Okay, Santosh is asking a question. What if it takes a lot of time? So Santosh, basically some questions are designed for brute force only, and other questions are different. So if you're not able to solve questions with some algorithm or some logic, you have to do brute force. But how do you find the question will allow you to do brute force? You have to check the constraints. If the constraints are really less, so then you can apply brute force. But if like in the last question, you can see that the constraints are really high. For example, they are like 10 to the power of 9. So in that case, you cannot apply brute force. And guys, I'll suggest you guys to like unmute yourself if you want to ask it out. Like it's hard for me to go away every time. Yeah. So 20 is clear. Um, Now the point comes over here. Point comes to like how do you find B? What is B? So now we know that 20 is one of the numbers. So what we will do is uh, we'll remove every divisor of 20 from this list, and what we will the list will become like, for example, if you remove all the divisors of 20 from this list now, so what will the list have then after like you have removed all the numbers? It will have all the divisors of the another number. For example, let's just remove 20 is the divisor, 10, 5, 4, 1, 2. So you're left with the divisors of another other number. So the next step is to remove all divisors of 20, and now the list is like this: 1, 2, 4, 8. And applying the same logic again, you can find that 8, same logic again, that is what is the largest of them all? That will be the second number. So now we'll take the max of this array and it will be 8. So through this algorithm you were able to find that 20 and 8 are the two answers. Moving to the method 1 code. So what I'll just quickly run through over the code. If you want me to, I can also write it with you, but I suggest this one. So again, instantiating a scanner class, taking the inputs. So now what we are doing is we are taking an array. We know that there will be n elements in array. Let's see. So this is one of the examples. This is n, and why is 10 over 10 given to you? Like you have to make an array of 10 elements. 10 elements. So that's why 10 is over here. This is the count of elements, and you're making. Now that you know n, you can make an array of 10 elements. So here is the piece of code that we are making the array. Now next to what you do is you run a loop and take every number and append it to array. For example, I goes from 1 to array length, and it's appended in the array. Like it's changed in the array, I would say. Now the first part from our algorithm, we know that the first number will be the maximum of the array that we have. So in this case, we had 20 as maximum, and this was one of the numbers. So we'll just directly know that number one is 20. So taking the max of the array. Next, what you do is next what we wanted to do is we wanted to remove every number, every divisor of 20 from this array. So for that, what you do is you run a loop from 1 to, okay, how do we find divisors first of all? How do we find divisors of 20? So for that, you run a loop from 1 to 20. You can also optimize it with square root of n. You can look it up on square root of 20. You can look it up on Geeks or Geeks if you want. So let's suppose we go by the nice way of doing this, 1 to 20, and if this number I, let's suppose we are running a loop, and if it's if it's divisible by your number, let's suppose 1 n, then it is one of the divisors. So like that's pretty easy. This is what we are doing. We know the number 1, and if this is divisible by this, percentage basically says that this is divisible by this. If it's 0, like if they are divisors of each other, like if it's a divisor, what you do is you remove from array. For remove from array, I made function over here, same as the functions we have in C. If you have doubt with Java, don't like look at the code in Java. Just understand the algorithm. Try implementing in C or C++ or whatever you feel like. So in remove from array, what we are doing, we are just basically doing simple stuff. Find the index that we want. We have the number over here. Find index of that number, and after that make a new array of length -1. So basically if you remove one number, the length of the array will be decreased. So in that case, we make a new array. After that new array is created, we'll skip only that number from the previous array and append all other numbers to this array. So this is the new array that that comes after we have removed one number from the original array, and you are simply returning it from here. So this is what is happening in this line of code. And again, after this whole loop has been completed, what you are doing is you are again taking the max of the new array, that is like this one. So after removing all the numbers, we were left with this 1 2 4 8. Again, you have to apply the same logic and you have to take the max out of it, which is 8, and this is your answer. Like you have to print it like this. Is it clear till now?
Yeah, makes sense.
Okay, cool. Yeah, also there is another method to do this as well. So you can easily see that there's a lot of code over here. Like you have to remove, you have to handle some edge cases as well. So that's a lot of code. Instead of that, we'll look into another method. So this is pretty decent, and like I would say it's classic method of doing such type of questions. So let's just copy. There are so many tabs. Just copy this in our editor. So this is the array that we are given with. First of all, what we will do is we'll sort this array. So after sorting, it will look something like this. 1, 1, 2 will be repeated twice. Then we have 4, then we have 5, 4 we have twice, then 5, then 8, then 10, then 20. So after sorting, as you know, we have first number will be the largest of all. So this is the largest of them all, and I'm sorry, this is the largest one of them all, and it comes to the last. So you can directly see. Okay, where is the code? Third method 2. Yeah, this is the code we are sorting the array, and we know that like array n-1. So this is basically the largest from this array, and this is one of our numbers. So that's what we are printing over here. And now the question comes, how do we find the second number? So here is where the trick comes in. So what you do is, this is your sorted array. You take a pointer over here on this 20, and you traverse in back, like in the reverse order. So first you are on 20, then you will go on 10, then 8, then 5, and so on, and till 1. Then you will break out of the loop. So that's how you traverse back in a backward fashion. And how do we find the second number? So we know that 20 is obviously not our is not the number that we need. So we'll move on to this one. So is 20 divisible by 10? Divisible by 10? Yes, it gives you 0. So that's not a number. For now, we are looking at one case only. We'll look at another one as well. Now you come on 8. So because it was 0, you skip this number and you came to another number. So now we are on 8, and it's not equals to 0. So you directly know that this is a number. So this is basically, there are two conditions in this, this one and this one. I'll show you that not I'll show you this that this condition won't run on every case, so that's why we have to incorporate two conditions. So till now it's pretty much clear that we have got a number that is 20 and 8, and we did the code in like 5 to 6 lines, so it's pretty short. Now comes the edge case part of it. For example, I showed you an example here as well. Let's just copy this one. So this is our example where this algorithm will fail, but we have to like take care of this. So we'll sort it again: 1 1 2 2 4 4, and last one is 8. So you know the first number will be 8, so we'll directly print it. After that, you have to run the loop from backward manner. First comes 8, so this obviously isn't the answer. But now now you come to 4. So when you do 8 percentage 4, it is equals to 0. It is equals to 0, and this fails our algorithm. How does it fail? Like only by seeing that, like directly by seeing, you can sense that the numbers, like the answer will be 4 and 8. Like you can see that 1 2 4, so these are all the divisors of 4, and 1 2 4 8, these are divisors of 8, so these will be the answers. But now the algorithm says that it will fail, like it is 0, so it will go to another number. Even though it's the answer, it will go to another number. So that's what we have to handle here. So how will we handle over here is, as it is sorted, we can directly say if these two numbers are equal. Like for example, let's just say we have a number 6. 1 2 3, these are the divisors of 6. You know that 2 won't be repeated or 3 won't be repeated, for like there will be only one unique 3 in the list of all the divisors of a number. For example, in 24 won't occur twice. Yeah, so are you getting the point? Like all the numbers, all the divisors will occur only one time. So that's the idea. As 4 is occurring two times, we know that these are one 4 is from the divisor of another number, and this 4 is the divisor of 8. So we know that like as this is repeating, what we will do is, if this number, like let's suppose array at I minus 1 equals to array of I. If these two numbers are same, we can like conclude that this is our number 2. Did you get this point? Can you confirm?
Yeah.
Okay, pretty clear, right?
Yeah.
So that's what we did here. Like, I'll just, so what we what we checked here is, this is the first condition that I told you. Like in the 8 condition, for example, I told you like 20% 8, that's not equals to 0. So this is one condition, and here you are handling the edge cases where the numbers are repeated. So if any of this condition is true, then you will print n minus 1, that is the last number from the array, that is 20 over here, and this one, this element that you have found out right now, and you will simply break out of the loop. And yeah, that's pretty much your answer. I guess it's clear now. You can also see the Python code. Python is like, but the syntax in Python is really easy, so that's why the code is very small. Yeah. Moving to the next question: Christmas and candies. Okay. What was the question? I totally forgot. Shadu loves candies. He has asked his father to buy candies from him. Okay. Yeah. So now I remember the question. The question stated that Shardul can like buy a pack of candies, but his father puts a condition forward, and that condition states that he has to divide the candies between him and his sister. And there is also one condition mentioned over here, that the division happens in such a manner that difference between the number of candies he and his sister receive is minimum. So you can like bold this, and you have to remember, like these are basically the pointers from the questions, and you have to take, like look at them properly. For example, this is very important in our algorithm, we have to incorporate this. So here's an example. I'll just simply go to the solutions tab. For example, Shardul chooses a packet of 6 candies. So the candies will be numbered from 1 2 3 4 5 6. And how do you divide then in optimal manner so that the difference is minimum? So In here, what we do is Shardul takes candy 1, candy 4, and candy 5, and his sister takes candy 2, 3, 6. In such a manner, in this manner, we can add these things 4 plus 5 plus 1. This will be 10, and 2, 3, 6. This will be 11, I guess. Yeah, it's 11. So 11 minus 10 is 1, and this is the minimum possible. How is it minimum possible? We'll see that like after we have gone through all of the solutions, like all of the inputs. Next, we take 4, 1, 2, 3, 4. So 1 and 4 comes over here, and 2 and 3, and the difference is 0. So this is the minimum possible. In example of 3, the minimum possible is 0. In 5, it's 1. In 7, it's 0. Do you see a pattern over here? Like the only two options that we are getting is 1 or 0, 1 or 0, 1 or 0. So these are the things that you have to take a look on in while giving the contest. So basically, most of the logical based questions. So there are basically two types of questions in like these 40 coding questions, coding concepts. Sorry, one is based on logic, and another type of questions are based on DS, like data structures, like arrays, trees, graphs, and all. So this is basically logic question. So in most of the logic question, like 50, I would say 50% of the logic questions, they're totally like based on patterns. If you see a pattern, if you can easily spot a pattern in your test cases, then you can code the algorithm really fast. So you can see it's 1 or 0, but it's 1 or 0. So this is an important thing to see in test cases. And that's why instead of directly jumping to code, you have to like consider five to six test cases. So you can see a pattern. Now, proving that only 1 and 0 are possible. So yeah, this is that time, and now we are discussing the how part. So let me jump over here. So let's suppose the input is 6. We'll have candies 1, 2, 3, 4, 5, and 6. So now you can like see that any number from 1 to n into n plus 1 by 2. So any number ranging from 1 to 6 into 5 by 2. 6 into 5 by 2 is 15. 1 to 15. Any number ranging from 1 to 15 is possible from this. For example, how is 8 possible? For 8, what you will simply do is you will 6 plus 2. So this is one of the logic that you have to remember over here. For example, you have to make 14. You can also make 14 from here. How do we make 14? These are the numbers that will add up to 14. Oh yeah, this is no. Sorry, like 14 you can easily make, right? Yeah. So you know that you can make all the numbers from 1 to 15 in here. So that's what I have wrote over here. Let's suppose sorry, 6 into 7 by 2, that's not 15, that is 21, no? 3 into 7, yeah. So any number possible from 1 to 21. So yeah, you get the point that from 1 to 21 you can form any number. Am I right? No? Yeah, no? Yeah. So now let's suppose the sum of the number is even. Okay. So you know that you have to divide it in two sets. In one, so this is the sum of like all the numbers from 1 to n. This is basically simple AP or arithmetic progression. Now you know that if a number is even, you can equally divide it in two parts. One will be n into n plus 1 by 4, and another will be the same, this n into n plus 1 by 4. But for example, if the number is even, let's suppose 21 only. So now you cannot divide it in two equal parts. It will be 10.5 and 10.5, and that is not the thing that we need here. So what you can do is, a floor function. I guess most of you know about floor and seal. For example, what is the floor of 2.3? Floor of 2.3 is 2, and seal of 2.3 is 3. So basically, as the number suggests, as the name suggests, floor basically means the lower bound, and seal basically means the upper bound. So you can divide this in this manner only. Like one can, so for example, you have 21. One number can be 10 and another number can be 11. You cannot do 10.5 and 10.5. So that's so that's what we have to take a look at. And now when you subtract these numbers like seal from floor, you will get 1. For example, 11 minus 10 is 1. And in this case, for example, if let's suppose we have 20, so 20 will be divided in two parts. One is 10 and 10, and the answer is 0. So this is our algorithm. Like this is the thought process behind our algorithm. So I'm sorry, I got to drink some water. Yeah. So this is again we use a modulo operator. Let's suppose we have 21. What is 21 percentage 2? It is 1, because 2 divides only 20 till 20 and 1 will be remaining. So you use a modulo operator over here. So for what does percentage 2 does? So if you have an even number, percentage 2 will give you 0, and if you have an odd number, it will give you 1. So that's what we are simply doing here. So it's just this code is just one line code. The only thing that you had to take a look on is that this pattern, like 0 1 0 1 0 1, and then you can simply reduce all these things. So that's pretty much about it. Is it clear? Like question D?
Yeah, yeah.
Okay.
Eve was the hardest of them all.
Yeah, I could say, like, yeah, E. If you are a starter, E. Yeah, E is hard, I would say. So what was the question? Where is our tab? Yeah. So Prakhar works at McDonald's. Also, I have to message Prakhar. Just a second. He also wanted to join in for E question. I'll just text him. Yeah. So he'll come. Yeah, Prakhar works at McDonald's. So Prakhar is basically one of my friends, and all the names that you like read in contest, those all are my friends. So you saw Vidit, you saw Shardul, and the third one is Prakhar. So Prakhar works at McDonald's. He loves eating junk food and blah 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 blah. Okay, so this question like gives you two options. So first action is to put one nugget in the box. For remaining action, he has to choose from two options. What are the two options? If the number of nuggets in the box is at least one. For example, you see, if the box is empty, you cannot eat anything out of it. Like you cannot take anything or any one nugget out of it. Like it's empty. So he may take it out. Let's suppose the nugget box contains three nuggets. You can take one out, and the total count will be now two. So that's what it is written over here. And the second option is that in this case, Prakhar will add one more nugget to the box that what he put in the previous turn. So instead of simply adding one nugget at each time, for example, in the first layer, let's just suppose in first step you put one nugget in the box. In the next step, you cannot put one nugget again. You have to take a look at the previous step. For example, in the previous step, we added one nugget to the box. Now you have to enter, like you have to put two nuggets now. In simultaneous manner, you have to put 1 2 3 4 5. Like this is the way the list will go. So here is one example. We'll just directly iterate over it. So this is just some random example. So in first step, he puts one nugget, current box capacity is 1. He puts 2, capacity will be 3. He eats one, it will decrease. He eats one again, the capacity will decrease again. Now, he has to put the nuggets again, like he has to choose this option. So what we will do is we'll look at the previous step that okay, we put two nuggets over here. So now next we have to put three nuggets. So capacity will be 1 plus 3, that will be 4. So again, like this is the way it will continue. And it is shown that in this example, Prakhar performs 9 actions. Like these are the 9 actions total, 1 2 3 4 5. Okay, you can count it, and it's 9. And the final count of the nuggets in the box is 5. You can see this is the final count, and he has eaten 5 nuggets. How has he eaten 5 nuggets? This is 1 2 3 4. This is 5. So he has eaten 5 nuggets out of this box. So it's pretty much clear till now. And moving on to the next part, you know that total number. Okay, now the question states that you know the total number of actions. Like for example, this like question gives you with 9 and the number of nuggets in the box at the end, and you know this 5. So these are the things that question has given you, and you need to find the total number of nuggets Prakhar ate. Like, and you have to find this number. So most of the times in competitive coding, you will find that the question is asked in reverse order. Had it been the in reverse order, the question would have been easy. So just to make questions a little bit tough, they ask in reverse order. So it is guaranteed. Okay, 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 this is cool. Now is the point that we have to take a look at constraints. So constraints for this question are really high. You can see that it's 10 to the power of 9. And in the first question, you can see like if you scroll up, you will see that n or g was still only 120 or 130. So you cannot like you can easily by comparing 120 with 10 to the power of 9, you can see like there's a lot of difference. So here you have to code a good algorithm, not just like normal code. So print a single integer, the number of nuggets that occur 8. So we'll quickly iterate over this example. See, we have 9, we have 11, and we have output as 4. We are given with 9, 11, and 4, I guess. Sorry, 9 and 11. So these are the two numbers that we are given with. Now it states that we have to find the output. How do we find the output? So what happens first is you put one nugget. You put one nugget in this like in this in the first step you cannot use the second option. Like as the box capacity is 0, you have to put one nugget at first. So the capacity becomes 1. Then puts 2. Capacity is 3. Each one nugget it's 2, 1 each one. So finally you come to a point that you have 11 nuggets, and you can count this that you have done 9 iterations. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, you have done 9 iterations, and the final capacity in the box, like final the number of nuggets in box is 11. So that's what we wanted over here, and you can see he has eaten like 4 nuggets. Now one thing to note over here, I'll just copy this. One thing to note over here is if you remove for example, if you put all the nuggets simultaneously. For example, you instead of like put one then eat one, then put one, then eat, instead of doing it this way, what you can simply do is put one, like put the first time, put the second time, put the third time, put the fourth time, and put it the fifth time, I guess here. Yeah, and then at the last eat. Okay, eat, eat, and finally eat. So instead of jumbling all these, you can simply do this. And from this, you can deduce that in the first, like in here, I'm writing the total sum now. In the first iteration, the total sum is 1. Then you have to put 2 nuggets. So it will be 3 now. So 1 plus 2, then 3, then 4, then 5. And now comes the eating part, minus 1, minus 1, minus 1, minus 1. So again, you can see that we are already looking at a pattern kind of thing in this question. So now when you solve this, it will be 1 plus 2, that is 3, 6, 10, 15, 15 minus 4 is 11. And now you get your answer. What is your answer? This is your answer. Like how many minus ones are there in this? Like, so how the total number of minus ones is your answer. So 4 is answer. So now we look at it in a different way. Now you know that the order doesn't matter. So now you know some bullet points. Now we'll simply directly jump into the algorithm part. So let's suppose we have 9. We'll simply write 9 numbers over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you know that you have to swap out some of these numbers, like some of these numbers from the last. You till now you don't know how many numbers you have to swap, but some numbers you have to swap with minus 1. For example, if you convert all these numbers to minus 1, all last 3 numbers. Okay, let's just suppose this is minus 1, this is minus 1, this is minus 1. Now what is the count? So this is 1, 2, this is 6, 10, 15, 21. 21 minus 3. 21 minus 3 is 18. So that's how you you have to think, like this is basically the thought process behind it. So you have 9. Now you have to figure out the number of times you have to put a minus 1 instead of these numbers from the last to make to get 11 out of it. Yeah, out of the example. I'll just quickly show you. Yeah, so that's what I have written over here, and we want to achieve a sum of 11. So we have to swap out some numbers and make them minus 1. So directly seeing the code, see what I have done here is how to find the number of my like minus ones we have to put over here. For that, what you can do is you can make a while loop. Okay, first of all, you make a while loop, and I is right now 9. So right now I equals to 9, and you have to calculate the sum over here. So what will be the sum? It will be of 9 elements, 9 first elements. 9, 9 plus 1 by 2. Okay, this is our sum. So that's what we are doing over here. And count is basically the number of minus ones we have put. So for example, this is our list on I equals to 9. Right now the number of minus ones, how many minus ones can you see over here? The count is 0. So you simply negate the number of counts from here. Now, as the current sum is greater than k, like what is the current sum till now? 9 into 9 plus 1, that is 9 into 10 by 2, that is 45. 45 minus 0 is 45. So as 45 is greater than 11, you know that you have to put more minus ones in this list so that you can get your answer. So you decrease your I count. That's how, like, I'm iterating over the while loop manually. So I equals to 8 now. So the sum will be 8 into, we won't be doing for every iteration, I'm just showing you 2 or 3. 8 into 8 plus 1 by 2, and minus the count of minus ones. Copying this, at the time of 8 we'll have 1 minus 1 over here, so we have to swap 1 minus 1. So now this is the total list, and what's the what's the sum of this? It is 8 into 8 plus 1 by 2 and minus count, and count is 1. So what is 8 into 8 plus 1 by 2? It is 8 into 9 by 2, that is 4 into 9, that is 36. 36 minus 1, so that will be 35. In the same way you have to calculate for everything. Now again 35 is greater than 11, so next number, that will be x. Let's suppose it will be greater than 11, but finally you come to a point that you have got 11 and it is equals to 11, so you break out a loop and you directly print the number of print the number of times the while loop has run. That's what we are doing over here. See, till the number is greater than k, like it's 11 over here, you have to increase the count and decrease I. So you have to take all the numbers, that's why we are decreasing I. Else, if the number is 11, or like it's the answer, you break out of the group and you print the count. So that's it. So you have got your answer. But what happens here is, if you submit this code on contest again, no, if you try to submit it, it will show you TLE. What is TLE? TLE basically says that it is time limit error. That even though your example, like even though what you have coded is might be correct, it might or might not be, but let's suppose it is correct. Even though your code is correct, but it is not performing well on time constraints. For example, it's taking too long because, as I told you, the constraints are really high, that is 10 to the power of 9. So this while loop can run to 10 to the power of 9 times. So that's not a good thing. We have to come up with some better example, like some better algorithm. Then again, how do you do it? Then we come to a then we again look at the examples. This is 9 11 4. This is the output. So array formed by 9 continuous number is this. Okay, 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 okay. Yeah. So as I told you, in example of 11, these last 4 numbers will be minus 1, and this is the first part of the array. If you take a closer look, we can apply binary search here. So this this line, if you are really beginning with competitive coding, you won't you cannot directly think of applying binary search over here. Even when I started coding, I started competitive coding, even I didn't know how to apply all the algorithms and what time you have to apply binary search, what time you have to apply something like sorting, or you get the point. It doesn't come to mind directly. This builds over if you have coded, if you have done competitive coding for 3-4 months, then it will slowly build. While coding, while setting the question, I knew that okay, yeah, as this is my first solution that I submitted on the platform. But yeah, this doesn't work, so I know okay, there's a better algorithm than this, and what can be what are the all types of the examples, that all types of solutions we can apply here. and then I came up with binary search. Okay, this is what we can apply. So how does binary search work here? Apply the binary search on this element. Let's directly take a look at the code. Let's take a look at Python code. So basically, Python code is looks like pseudocode. That's why we are looking at it. So how does binary search work? So you set I to 0, you set j to n. So these are the total, like one is at the start, one is at the beginning of the number. Now, while I is less than equals to j, in the first iteration, 0 is less than 0 is obviously less than n. So we'll go into this while loop. Now binary, I guess most of you know what binary search is. Yeah. Can you
Yeah.
confirm? Yeah. Okay, good. Okay. So in binary search, the first step is to find the middle element. So how do you find the middle element? 0 plus n. Okay, this is the way that you find the middle element. So what is the middle element in four numbers? 1, 2, 3, 4. It will be the second number. So you apply this method to let's suppose you have 5. What is the middle number? 1, 2, 3, 4, 5. The middle element is 3. So that's what we are doing over here. Find the middle element. And now okay, how do I explain this? This is let's take this example only. Just another like I'll take just another 5 minutes. We'll complete this quickly. So we have to apply binary search on this. Let me copy this as well. So we are given this line, like 1, 2, 3, 4. We know that this is a line, and we want to find the number of minus ones we have to find. So in binary search, basically your time complexity reduces by log n. For example, the time complexity is log n. So if you search for 8 in this number, 8 in this like in linearly manner, so you have to look at all numbers 1, 2, 3, 4, 5, 6, 7, 8. But in binary search, what will happen is you first of all you look at the middle element. You look at 5. Then what to do is, okay, 5 is less than this, so you will move to this part. Again, you will look at the middle of this. This is 7. Okay, 7 is again small. Now you look at this chunk of code, chunk of array, and now you find that okay, 8 is the middle element, and it is so you find it in 3 shots. And in linear search, you are looking at for 8 times. So that's the thing like that improvises binary search over linear search. So that's where complexity comes in. So first of all, what we'll do, we'll look at 5. We'll 5 into 5 plus 1 by 2. Okay, what is 5 into 5 plus 1 by 2? 5 into 6 by 2, that is 5 into 3. That is 15. Am I right? It's 15 only. Yeah, it's 15. And now you can take a look at that, take a look at it in this way. Till here, the answer is 15. If you negate the count of these numbers, for example, how many numbers are there? 1, 2, 3, 4. So if you separate 15 minus 4, it will lead you to 11. And that's a desired result. So that's what we are doing over here. Let's suppose 1, 2, 3, 4. Let's take another example. Do we have another test case? Let's take it manually. 1, 2, 3, 4, 5, 6. And you have to search for example, 1 plus 2 plus 3. That will be 6. And you have to like 3. You have to search for 3. Like if 3 can be made from that. So what you will do is, first of all, you will take the middle element. The middle element is 3. What is the sum? 3 into 3 plus 1 by 2. 3 into 3 plus 1 by 2. And that will be 6. Now, you look at the elements after this. Like this is our current number. You look at all these elements. So these are 3 number. If you subtract 3, you'll get the answer as 3. Yeah. So this is a desired result. So that's what we are doing over here. See, this is the target. So basically n minus m, and what is this? So basically this is the sum. Yeah, this is a n minus bit. Okay, this is the target. For example, middle element. Okay, middle is basically the number, and you are calculating the sum over here. And this is basically n into n plus 1 by 2. We just have swapped n with n minus bit. So calculate the sum. And if the sum is equals to if the sum minus mid, what is sum minus mid? Sum minus middle element shows you this, and mid is basically the count of the like last part of the array. So if the target minus mid equals to k, you have to print that mid. But if it's not equals to, like if it is not equals to a k, what you have to do is you have to handle the j or j and I pointers. So in simple binary search, the same thing we do. If, as I told you, like in this example, we were searching for 8, and this was the first number. If 8 is greater, we know that 8 is greater than 5, so we'll go to this part. So we did mid plus 1, and in another, if it's less than, then we just do mid minus 1. So yeah, that's pretty much the algorithm. If you like, if I know you will still find it difficult to code and difficult to understand, but if you run over like 5 3 examples or test cases, you will better understand the algorithm. So I said what I suggest is you take 3 4 random examples from yourself. Imagine some examples, write them on a piece of paper, and then you will you can then find out that okay, this is not magic. Like this actually works. So that's how you build a thought process. You can also look at Python code. This basically looks like a pseudo code. Yeah. So we have done all the questions. Any doubts till now? I think it's clear. So for the next contest, what I suggest is you do some questions from HackerRank. I'll just type in HackerRank questions. Solve practice questions. Yeah. So basically, this is HackerRank. You have to, like, if you want to get good at competitive programming. Let's suppose take example of Kabir and Jackson. So these are fourth year guys, and like they came first and second in the contest. So how did they start? Most of basically the successful competitive coders, they start with hacker. There are many sites like HackerRank, Decode, Code Forces, Code Chef. You have to pick some questions out of these every day, like 2 questions maybe, and then try to solve these questions. So basically, this will develop your thought process, and once you have developed the thought process, no, competitive coding is like really good. It will get really good. For example, Jackson and Kabir, they both solved the paper in 58 minutes. Like they were like seeing the problem, they were coding. So you can get to that point also. Yeah. So at that point of time, it really gets good. And one thing more that I would like to say, for example, even if you solved one question, no, it would have been really great, like to see if the question has been accepted. Like you tried for 4 to 5 times for question B, or let's suppose question A, and it says that it has been accepted the fifth time. So I presume that some of you might have been like felt that okay, so I finally submitted one question. Yeah, so that's what I just wanted to say. Like keep practicing, and yeah, so that's it. Do look at HackerRank and some of the questions, and also try to solve all these questions again. If not all the questions, but the questions that you weren't able to complete in the contest. So yeah, we can end now.